Summer is baseball season, so we have a baseball question, and we want to find the position and velocity for the ball, and we want to find how far the ball travels horizontally. We'll do the next parts, C and D, in a separate video. So what do? Well, we start with what we know, and what we know is the acceleration of the ball is 0 horizontally and minus 32 feet per second squared vertically. That's just the acceleration due to gravity. That's the negative gravitational constant in feet per second squared. So we have our acceleration. Now we know velocity is the integral of acceleration. So we're going to integrate the acceleration, and that is going to give us a constant. The integral of the antiderivative of 0 will be a constant c1, and then minus 32t plus c2. The integral of the integral of 0 will be c1. The integral of negative 32 will be minus 32t plus c2. So that's our velocity. Now we have some information. We know that the velocity at time 0 is 80, 80. So that is our c1, comma, minus 32 times 0, because this is at time 0. So we put a 0 in for t. And that gives us the fact that the velocity, that gives us the constants c1 and c2. So the velocity is 80, comma, minus 32t plus 80. And that is one of the questions that we were asked, was to find the velocity. So there's the velocity as a function of time. So we're halfway done with that part. We were also asked to find the position. We know the position is the integral of the velocity. So we integrate again, and this time we get 80t plus, I'll use c1 again since it's not being taken anymore since we found it, minus 16t squared plus 80t plus c2. So there is the position, and it has a couple of constants of integration, c1 and c2. But we also know the position at time 0. We know that it's 0 and 3. It's 3 feet above 0, 3 feet above the ground is what it said in the problem statement. So 0, 3. And that means r at time t is going to be 80t, 80t, comma, minus 16t squared plus 80t plus 3. And so that will be our position at any time t. Notice the y position is a parabola, the minus 16t squared. So the trajectory of this ball is as expected. It's a parabolic trajectory on the ball. So that was part A. Part B asks us something else. It asks us how far does the ball go horizontally. To know how far it goes horizontally, remember this is the path or the trajectory of the ball. And there's the ball itself. And when does it hit the ground is what we really need to know. So v of t, the y component of the velocity, the y component of the position, y of t, is minus 16t squared plus 80t plus 3. So when does that position, we want y to equal 0. That's when the ball hits the ground. So we set it equal to 0 and set y of t equal to 0. We use the quadratic equation to solve. And that's going to give us two solutions. It's going to give us a negative 80 plus or minus the square root of 80 squared minus 4 times minus 16 times 3 divided by 2 times negative 16. And what we get is a negative 0.04 seconds and a 5.04 seconds. Of course, the negative 0.04 seconds is not the answer we're looking for. We don't want a negative time solution here. So it's 5.4 seconds. That's the time at which the ball hits the ground. But the question says, how far does it go? So we evaluate x at 5.04 seconds. and that's 80 times 5.04, and we see that it has gone 403 feet. So there it is. That's the horizontal distance at the time when the vertical height is 0, and that's the answer to part B. So there we go.